Okay, I think we are ready to get started here. So it's with great pleasure that I introduce both John Krouse and Andy Brayman, both of whom are, of course, co-organizers of the workshop. John, as I mentioned before, is a ceramic engineer and the CEO of Boston Valley Terra Cotta. Boston Valley specializes in the manufacturing of historic terracotta replication, new construction, and innovation in contemporary rain screens. John is a graduate of Alfred with a BS in ceramic engineering and a minor in ceramic sculpture, and has over 30 years of experience in terracotta manufacturing. Boston Valley has successfully completed well over 3,000 building projects, with John leading the company. With John is also Andy Brayman, who holds a BA in sociology and a BFA in ceramics from the University of Kansas, and an MFA in ceramics from Alfred University. His work is a combination of traditional craft, industrial processes, physical computing, and contemporary art strategies. At their best, his pieces demonstrate an object's potential to be both beautiful and cerebral. In 2005, Andy founded the Matter Factory in Kansas City. It is part artist studio, part laboratory, and part factory. In addition to producing objects of his design, Andy also conducts research on glazes and forming methods for Boston Valley Terra Cotta, which he'll share with us today. So with that, both John and Andy, please take it away.
So my talk is about specialty louvers on a project in the NoHo district in 688 Broadway. And as you can see from the photo, the louvers themselves were very unique in shape and design. They were well thought out and crafted by BKSK, who is the design architect. And they were, they had to be extremely sensitive to the historic neighborhood right there in that NoHo district on 688 Broadway because of the amount of terracotta and brick surrounding the structure. So in moving forward, I'll address all that, but I think what we really had a lot of fun with was working with Christine on the glaze with the architect and developing the finish that really complemented the brickwork and fit into the vernacular of the neighborhood, so it didn't jump out and look too modern. And also just the sheer design and the shape of the louvers were so unique. I thought it was important enough to highlight this as part of our presentation for ACAW. So let me go to the next slide. So it was 688 Broadway and also One Great Jones Alley. So there's this lovely hidden alleyway to access the backside of the building, which was redesigned and laid out by BKSK. And they really did a fantastic job of using modular terracotta and an interior-exterior application that really kind of drew you in with your interest. There was a reflection pool that takes you into the reception area and so on. So that was kind of fun just as an offshoot to the louver job, but I just wanted to mention that because I think they really study their materials and kind of were looking for a certain finish that would bring the whole project an added bonus of specialty finishes. And I think the terracotta really answered the call for them. In working with BKSK, it was a mixed-use residential development in New York City in the NoHo district, as I had mentioned before. And the main residential entrance to the Great Jones Alley featured the custom tile. And again, that just gave the whole project a really nice small-scale application of using terracotta where you can transition it to the inside of the building and bring a human element to it. And then these massive louvers that were used on the outside of the building that added this unbelievable dynamic feature in front of the window wall system that they featured. One of the things that we found out when we were working with the entire team, including the consulting facade engineer, BKSK, and the contractor tasked to put this thing together, was with the complexity of the design, there really wasn't a lot of time to do two separate mock-ups. Once we got into the engineering of the system, working with CDC out of Dallas, Texas, we started to realize that we had to deliver this material a little bit sooner, and we had to compress the schedule. So it was agreed by all parties that the PMU would also act as a VMU. So I know there's a little bit of risk in doing that, but there's also some time savings and some cost savings. So that was something that was considered on this project, and everybody agreed to use that. So these louvers were pretty massive. They ranged in 6 inches in section and 18 inches wide, and then there were half units that were 6 inches by 9 inches. So the mock-up was fairly large. It represented an entire width of a pier, and it featured 5 louvers. And on the side, you can see the section detail, which is just a general overview, but in a second, I will show you the cross-section right through that section so you can see what the engineer was up against. These pieces probably weighed close to about 220 pounds, the full size units. And when you stack 2 on top of themselves, we were probably upward of around close to 500 pounds of weight that had to be supported. So that was an added design challenge for the engineer. And CDC did a pretty good job of figuring that out. And we've worked with them in the past on other complicated work, so it was kind of nice to have a relationship with the team and go back and forth with suggestions and ideas where we could help them make their engineering problems a little bit easier to solve. The next section I'm going to show you is, they're very similar, but slightly different. Kind of like what Susan was talking about and what Roberto were talking about. They kind of all look the same, but there's lots of different complications with iterations of the same piece. So you really had to pay attention to that with all the anchoring details and the clips and so on and so forth. I think this probably best illustrates the size of the terracotta. You could see the aluminum spline, which we worked hand in hand with the engineer to custom engineer that double spline attachment in aluminum. And then the custom gasketry that was used, that was supplied by our vendor in Ohio. And all the components that come together. There's a bottom plate, a top plate, a lot of machining and drilling and tapping and so on and so forth. At the end of the day, the contractor decided to take all that away from our contract, so it kind of made it a little easier in some regards, but all it did is pass it over to the next person, and we still had to work hand in hand with the entire team. So there was a lot of collaboration with the group for such a one-off project. This explosion or exploded view of the anisometric really kind of shows the amount of clipping and the hardware that went into the support system to hold these louvers up. And, you know, everything's kind of beefed up because of the weight that you're trying to support. So there are advantages and disadvantages when you're doing louvers of this size. The advantage for the architect is it's a one-piece assembly, and it is not interrupted with any seams or open joints. But on the other hand, it creates a level of complexity for the attachment system and the weight that you're carrying. So, but I think the pros outweighed the cons on this, and the design overruled the simplicity of cost. At least that's my interpretation, but I'm sure the architect would agree. So this is the construction of the PMU at the testing facility. And for us, we were invited to come take a look and snoop around and take some pictures of all the fascinating hardware that was used, and also kind of understand the level of complexity that the system proposed, and some of the things that we had to make adjustments to when we went into production. For example, certain cuts had to be notched differently to allow for the mechanic to get his hand in there and tighten down the hardware. So there was a bunch of like hidden details similar to Susan's talk on the suspended dome. We did not have the luxury to do it all in foam. We opted to cut the dies and run the shapes and then basically just shortcut it and go right to the PMU, which acted as the VMU, and so on and so forth. You'll notice, though, on a close-up inspection on the slide on the right-hand side, the glaze had a wonderful patina on it that was something that we talked about with the architect and had to come back and figure out how to basically antique the look of the glaze. And I'll talk about that a little bit later on a few other slides. There was quite a bit of testing that was done on that PMU. Most curtain wall assemblies go through these rigorous testing regimes with the terracotta added to the system. Obviously, the ASTM testing for C67, freeze thaw, compression, effervescence, those are pretty standard. In New York, they like to see 300 freeze thaw tests done on a product like that. That would replicate about 10 years of simulation. Also, the modulus of rupture, which is very important, especially in curtain wall applications or where things are put in tension. And then you have the C126 chemical resistance. That's basically the acid rain. See how the glaze holds up. Everything passed fine. And then the other battery of tests that were done were E283, E330, more for pressure and wind load and water infiltration, things of that nature. And then last, the AMA 501.1 for the exterior window curtain wall system, doors and water penetration. For dynamic pressure, I believe they had to go through a couple rounds of that where they might have been experiencing a little leakage. And a lot of that is really dependent on the waterproofing details that are used on these systems to make sure that they're properly done. And then the last one is seismic drift. Yes, they do get earthquakes in New York, so that is a concern. And everything passed with flying colors. Again, I had mentioned about the use of turning the PMU into a VMU to save time and cost, and that was definitely utilized in this project because it was starting to go over budget. So that was a decision that the architect allowed. The testing was done at Intech training facility in Reading, Pennsylvania. And when you are working toward that slot or that opening at the testing facility, you really can't miss that date. Otherwise, you're back at the end of the line, and it could take 6 or 7 months to get that test queued in again. So it's really important that everybody stay on the same page and meet that target date to get your material into the testing facility. So that was kind of what was driving everything on this project, was we cannot slip on that date. So other than that, the mock-up material was test fitted at Boston Valley to ensure proper dimension, fit, alignment. We were even able to blend the tile a bit because of the range that the architect had requested in the glaze. And by doing that, we were able to package it in a way that allowed the contractor to install it without having to worry about blending too much of it in the field. So, but we did check every piece. We stacked it on top of itself. We confirmed it with our quality control sample for our glaze approval and tolerances and so on and so forth. So when you manufacture custom parts like this, you don't really have an opportunity to get into a really full-blown production because it's kind of a short run of a specialty shape. So you always encounter some type of issue or problem when you take on these kind of jobs. One of the issues that we had to learn how to do was how to prop the piece up and support it without getting dented or chipped up, just transporting it on our drying rack system. And you can see on the photograph on the left, we engineered some foam shims which were able to support that piece and keep it from rocking and tipping and ultimately not chipping the piece up. And then later, we also had to make similar refractory supports at that same angle for firing the parts in the batch kiln. This particular job, the glaze was wrapped all the way around on all four sides. So that forced us to do a twice firing application and gave the architect the look that they were looking for. But there was no other way to do it other than to bisque fire it laying down, remove the pieces from the kiln, machine them, and then send them back up to the glaze department to preheat them, and then put the specialty glaze application on. The picture on the bottom right indicates the target that the architect was shooting for, and then the photograph on the top right indicated the extreme range of the antiquing that was applied on top of the Christine Yetton, almost like a pearlescent kind of finish with an antique splatter coat applied on top. So we probably put about 8 months worth of time into perfecting that finish and working with Christine, and I believe she flew back and forth to our facility at least twice to work with us to understand how the glaze would behave on a tall vertical application, and also just to work out any of the adjustments in the glaze, which were done in-house by us to modify her finish to get the glaze to actually mimic what she had done in the studio, but ultimately deliver what the architect was looking for, which was this beautiful pearlescent kind of shimmer with this antique finish that matched the brick that was delivered from, I believe, someplace in Europe, either Denmark or Holland. So it was a real challenge, but it was a lot of fun. And what you're seeing in the photograph here is probably illustrates the best of all the unique little adjustments that had to be made in a standard part. You know, the piece on the top was custom cut on a diamond wet saw to fit around the metal head detail that went above the windows. And then down below, there was also a notch that had to be provided in the terracotta to allow for that feature that was running horizontally through the system. And then that middle center aluminum bar also included, concern to make sure that all the hardware fit properly on the terracotta before everything was fastened onto the metal structure and the backup structure to receive the terracotta. So it looks easy in the photograph, but it was quite a project in putting it together. So for sure, lessons learned were you can save some money and time if you decide to combine the VMU with the PMU. And on small projects like this that are this custom, that's something to consider. Coordination and timing were key in engineering the spline and the gasket. A lot of work has to be thought about before you can just design a die to extrude the shape. You have to think about the wall thickness, how to support the material coming out of the die without collapsing and losing dimension, the size of the spline, the thickness, and all that had to be carefully considered and engineered before the die was even cut. Then the early communication between the facade consultant, facade engineer, manufacturer, installation contractor, and ultimately the architect. On jobs like this, to get them to run smooth, you really got to get all the parties coming to the table and working together. There's not a lot of time to sit on things and wait for the other person. You really have to initiate the phone calls and get the dialogue going. And then collaborating with Christine was, it's difficult overseas, but once the artist would come and visit and spend time here, they gain an appreciation of what the glaze looks like when it comes out of a gas kiln versus an electric kiln, and the adjustments that have to be made. So I've worked with Christine for many, many years, and we have a great relationship of how to cooperate and deliver what the architect is working for at the end of the day, and really meet the design intent. I also provided a full-size piece behind me here. I don't know if everybody can see it, but you know, it just gives you a little bit better appreciation of the size of the part and the beautiful finish that was put onto the louver that makes the project such an award-winning job. So I think the architect was extremely pleased. I know Landmarks in New York is really happy to see this type of design work going on in historically sensitive areas. So it's really a win-win for everybody when they can design beautiful one-off louver projects like this that fit into a really historic sensitive area of New York. So, you know, with that said, I'd like to turn it over to Andy, I guess, and go from there. Are there any questions that we want to?
Yeah, maybe, John, there are just a few questions. It may be easy because to answer them now. Just the definition of PMU, VMU, just the difference between the two.
PMU is performance mock-up. The word testing wasn't used. Sometimes they refer to them as performance test mock-up. And typically, the engineer, facade engineer, will recommend a complete full section of the building, from including an entire window assembly to the head to the sill, and one pier wide. And that was what was agreed on by the facade engineer, James Gainfort. And you know, you can keep going bigger and bigger, but I think on a project like this, that was all that was really required to meet the testing requirements for the city of New York. And VMU stands for visual mock-up. When you do stuff like this, you really get, you have to get a sense aesthetically what you're looking at, and there could be adjustments that need to be made. However, when we worked on this job, we did develop a charrette, which was about 1/4 scale, the size of the louver, and a lot of our research on the glaze application was done on that charrette way in advance, so we didn't have to lose a lot of time glazing full-size parts before we went into production. But that's the difference between the two.
Just one other question before we move on to Andy. It had to do with, have you ever had any problems with efflorescence? If so, what was the solution? It may be about iridescence, maybe about how they glaze. I think that may be what the question is.
No, we've never experienced any effervescent issues. Effervescence, I think, is more related to a lower fire glaze. This material is fired at a mid-range at around close to 2100 degrees Fahrenheit. And they do test for that, but this particular glaze passed all those tests. So it's pretty well bonded, and it met all those requirements that ASTM was looking for.
Super. I guess we're ready to take on Andy next.
Okay, thank you.
Great, John. That was really cool. All right, let me share my screen here. Okay, great. So my talk is about glazes and really sort of the expanding world of glazes, and I'll kind of get into what I mean by that here. But first off, I want to thank John Krouse and Boston Valley, the whole team there, Omar, Mitch, everybody, the people here who work with me in my studio, Chris Burke and Joey Watson, that are a big part of what I do, and I couldn't do it without them, so I'm going to say that right from the beginning. Okay, so what we're looking at is a glaze that is on the tan body at Boston Valley. That's sort of the default setting for all of my testing here is the tan clay body they have. It's a beautiful, super strong body. And this is a glaze that would be fired in their normal firing settings. So when John and I started working formally together, we really were looking at setting up a situation where I could do testing that would be as close to their production facility as possible. And so all the tests that I'll show in this slide deck are things that should be achievable in the larger kilns in the typical firing cycles. Okay, so let's see here. So next image. Okay, so this is a slide that some of you may have seen before. I showed it in the last ACAW, and it's something that I have been working on in collaboration with other people about sort of dealing with a terminology and a taxonomy when it comes to talking about architectural glaze, and sort of being able to describe that. I mean, glaze is such a expansive world, and sometimes the words we use to sort of describe it and paint the picture of what an architect is looking for, or it can get difficult to describe certain things. So this is kind of really looking at the obvious things first, of course, would be glaze finish and opacity and color. And the tricky part really is where things get sort of weird with glazes, right? Where we talk about variegation. And so to sort of borrowing some terms from studio ceramics and other industrial ceramics of sort of describing some of that here. And some of the samples I'll be showing will contain, of course, many of these traits: floating, breaking, luster, rivulet, pooling, and on and on. This is the test kiln that's sort of large for a test kiln, so it's a small production kiln, really. But this is what all the samples were fired in that we'll be looking at. And what we do is I fire typically on a standard rain screen cycle that would be used in the large kilns at Boston Valley. So it's a little less efficient time-wise for me here, but it matches their conditions really well. So for ACAW, this is exciting, but this is really the second year using this kiln for ACAW. And it's interesting because a lot of the glaze development that's happening is really close to being able to be tried out in full production. Okay, so when thinking about sort of the idea of talking about glaze and where glaze might be headed, both for Boston Valley and then in the larger context of architecture, I kind of break it into three basic categories, right? Really visual beauty being one of the main sort of things that glazes are so good at, and they're so sort of wonderful as a surface, is just their sheer beauty. Then also sort of related to that, it would be any sort of a narrative or a story that might be told by the glaze itself, that might be specific to the glaze. And then the third thing is sort of environmental choices in terms of materials used and any kind of performance related things that are related to the glaze. And I feel really strongly that things are expanding in all three of these categories, and that there's really exciting research being done. I mean, in large part, I think things like ACAW really help push what is possible, and gives firms and Boston Valley and outside parties a chance to sort of do research. So that's the overall kind of framework for where I'm going to talk about. And so this is one Vanderbilt, a slice of this. We saw some pictures of this earlier today. And I think that this is a great example of sort of just a visual beauty being one of the main traits of this glaze. That's what this glaze brings to the table. I think Bill Carty has sort of described how the glaze isn't something that's making the clay body stronger. And that's something that when you're learning about architectural ceramics, that you sort of learn that early on, that if the glaze has sort of crazing in it, little cracks, that's not an indication that the clay body itself or the structure is at all in trouble. And so in many ways, the glaze is is visual and tactile and not structural. This is the Rathbone project in London. And I put this in as a kind of representative piece for kind of the narrative or the story part of it. And I don't know the whole story, but I think I heard that there's a bracelet that the client had that was sort of the inspiration for both the color, and it just so happens to be sort of the shape as well. And so that there's that sort of backstory that someone walking down the street might not know, but I love, and I know many architects and lovers of architecture love the sort of layered meaning in the details of the sort of built environment. And so the glaze, there's an opportunity for the glaze to hold part of that as well. And then this is an example of one of the early tests I was doing for Boston Valley with recycled glass as a main ingredient in the glaze. And I'll just sort of go through some of that. And so that sort of more speaks to kind of environmental choices in material selection. So these all contain post-industrial glass, or yes, post-industrial glass. Some are from the sort of plate glass industry. Some are the borosilicate lab glass industry. There's different industries that we're sort of tapping into to use material that they consider to be waste as a replacement for a material called ceramic frit. And so doing this type of project, there's a fair amount of risk involved, right? In the sense that what's not particularly hard is to make a small test tile that's really beautiful. But then there's a risk in that scaling up isn't feasible, or you end up in a totally different place. So by working with John, who's a real sort of systems thinker for sure, and I mean anyone who works in ceramics needs to be a systems thinker, because there's so many variables that are interrelated to get to the finished piece. We've had to sort of approach and take on the idea of using sort of a variable material like a post-industrial waste as a main ingredient, right? And so one of the ways that I've started to do that is to use some of the tools of conventional ceramic engineering of understanding glaze. This is what we're looking at is called the Stoll chart, and it maps glazes both in their alumina and silica ratio. And it gives you an idea of where they lie on a grid that defines gloss to matte. And so this is just some early testing from maybe a year ago now of sort of mapping out different regions, and then sort of doing this three-dimensionally to assign other attributes to individual glazes, really to begin to learn what's happening and what sort of the glazes are doing and why. And so I just use this internally as a way of sort of understanding some of the results that I'm getting and to be able to follow leads or to solve some sort of problems. One of the things I think about when I think of glazes is it's not a single sort of recipe or a single glaze. It's really like this sort of family of glazes. I think of it more three-dimensionally. It's like a sphere. You know, you could really map these things three-dimensionally. And that's a useful strategy, I think, because sometimes you get variation coming out of the kiln and you want to know what direction you need to move to be able to kind of nudge the glaze to the area that the client would need to go. This is just some testing stuff. This is kind of just demonstrating and showing. I'm using really the same tools that a lot of architects are using in terms of understanding materials. And so now we'll get into some more tests, right? And so, I mean, glazes are, if we go back to one of the categories of sort of the story or the narrative, one of the things that I think is interesting about glazes is that they're sort of a simulated geological process. They're made from materials that come from the earth, and heat and pressure are used to fuse them together in ways to create, durable, interesting surfaces. And so it's this sort of simulated nature is really what this is conceptually, I think. And it's an interesting way to think of it. And I think it makes it so much more interesting than sort of powder coating or paint or something like that. So go on from here. So this is just a small snapshot of just like one version of a type of testing regime where the orientation that the tests are fired in can play a huge factor, and you want to know this early on, how much a glaze flows. Does it cool differently when it's on a vertical surface or a slanted surface versus a flat surface? And then you can see there's a sort of pyrometric cone. That's what tells us sort of where we are as a way of checking that things are melting in the right way at the right temperatures. So I'll just keep scrolling through. So this is an idea for people who aren't or weren't on any of the ACAW teams this year. This is an example of what I maybe would have sent a team or multiple teams. And it would be a sort of testing regime for one particular glaze. In this instance, it's glaze VBO5B, and this is it over different engobes on the right. And so it's on a textured tile. And these would have been fired at, as you can see, it's fired at roughly 75-degree angle. So it gives some information to people, sort of pretty succinct, where you can start to sort of see and know what direction maybe is interesting as the person sort of designing. One of the tricks, of course, with glaze development is that it's endless. It just goes on forever. I mean, you could spend just a lifetime exploring a very small area of glazes. So you really have to be able to step back and or help other people step back and sort of see a bigger picture maybe. And so these are sort of early stage. Obviously, the test tiles are pretty small. These are about 6 inches in length. And it's just enough to sort of get a lot of tests into the kiln, get them out, maybe send them in the mail. And then it really sort of doesn't even count yet until you get it on a larger piece. You get it on something representative of the geometry that the client would be working with. And so now I'm going to show a few pictures that are specific to particular teams. So this is for, I'm not going to show any projects because that'll be tomorrow, right? That'll be left to the people that really design the pieces. But this is an example of sort of a team looking at wanting to explore iridescence or reflectivity in a glaze that isn't a standard type of glaze. And sort of where we got this thing on the top, this long piece that has this sort of crawling, that was a mistake. That was really something from another test that I was exploring on the side, not for any particular group. It was supposed to do something entirely different, but it resulted in this sort of gold-like iridescent effect. And I removed the piece that was the element that caused the crawling in order to get to a glaze that had a strong iridescent effect. And that's ultimately what that group ended up going with. So there is some sort of luck and chance in when casting a wide net in terms of testing. So this is the same glaze, just viewed at different angles, right? So sort of mother of pearl scenario. But this needs to go through further testing. I mean, John explained sort of the testing regime that was done for the project in New York, where you would do the C126 test for ASTM to see, like, how does this hold up over time? And through working with ceramics for a long time, I know there's certain categories of finishes that are suspect in terms of they may or may not be durable enough. most standard glazes, well, I would say all of the standard glazes of Boston Valley are just like so tough that, you know, they're going to pass with flying colors. But when you're doing the research into new things, new materials, it's something that, you know, you want to be, and I need to be aware of early on, of sort of how fragile is the material. But in general, the glazes are incredibly durable and strong. So some of these tests, of course, are, I mean, we're viewing this from such an exaggerated angle. I mean, you'd have to have your nose practically touching the building to see a glaze like this on a building. But I'm aware of that, and that's part of the process of sort of like figuring out what works from different viewpoints and from different angles, and where is there sort of room for expanding what glazes can be on architecture. I think this class of glaze, which I would say is sort of something that varies widely in terms of how light hits it, is a type of finish that has a ton of potential, and there's plenty of precedent for this type of finish being used successfully on projects. Here's a detail of the PLP project that we'll see some tomorrow of. This is a crystalline sort of glaze that has a pretty dramatic color reaction based on cooling. And so here we can see there's this sort of pinholing, right? And so there's a big part of the discussion when we talk about glazes, which is sort of a kind of feature or flaw discussion, right? And for as much as architects, artists, designers sort of maybe want to see themselves as not being super controlling and rigid about the final product, I think we all want to exercise a certain amount of control over what comes out of the kiln. And ceramics is a sort of, if you need things to be super precise and super exacting and super uniform, you do sort of paint yourself into a corner that is exactly that. And so there's lots of, I think, interesting work being done where flaws are incorporated or accepted or used as part of the piece. And the history of ceramics, of course, is full of that. Glazes that could be described as having particular flaws, but really aid in the beauty. And pinholing is a particular thing that I know that lots of work is put in to minimize it. And it's a complicated problem. In this case, it had to do with the color of the stain that was used to color the clay body itself dark. So no pinholing at all on the tiles that are the body that has no stain, and then pinholing on the ones that do. Here's a little details, a teaser of a KPF project that we'll see tomorrow. This is a 50% recycled glass making up this glaze. Here's a detail of a kind of crawling glaze that LMN has explored a little bit with my help, and sort of a variation on that, sort of changing up the color. The scale, of course, this is probably, we're looking at a 3-inch by 3-inch section of the piece. Okay, and then I'm going to just zip through the last couple images here. This is a ceramic lobster that at Boston Valley had asked me to help make as a kind of like a promotional and just sort of like a experiment to do of making some glazed lobsters, really based off of some observations that Dorina had made from KPF last year. And so here are some ceramic versions of this lobster with glazes. And what's notable, I think, for these, for people who are working with Boston Valley, is that these are all single fire firings done with conventional materials and fired in the cycle that they fire their rain screen at typically. And so one of the things that Boston Valley does is cool the kilns relatively slowly, of course, because of the thermal gradients on large pieces. And so with that slow cooling, you get the opportunity to have crystal growth if your formulation is correct and if you want that. So that's what this is. This is a different glaze. And yet another. Okay, so now the last several slides would just be a few more just close-ups of some of the tiles themselves that were sent out to different teams. And the sort of ridged surface. You know, in my mind, as somebody that works in ceramics and has for a long time, I know that when you can sort of integrate the glaze with the form, and if there's texture, it's sort of integrating that and kind of having a feedback loop early on usually sort of gets the project to a place where things really sort of sync up and become really sort of enhance each other. And so the last bit will be a little bit of experimental stuff. I think I've shown some of this before. This would be a glaze window research that I've been sort of exploring for a while now, and is sort of on the table to kind of see about taking it further for architectural kind of setting. This is a little bit of research from a while ago about using lusters and conductive. This is for LEDs, but you know, for sensor applications and some printing here and there. And just to kind of end on one shot of John and somebody from the KPF team last year cutting up the pieces. So I know everybody involved in this year's ACAW wish we could be there, and hopefully that's next year. And I'll just end on the last thing about the sort of environmental side of things. If really looking forward further, I think the most interesting work that could be done has to do with some of the research with geomicrobiology and biomining and bioleaching. So earlier in the day, Bill Carty mentioned this bumper sticker, which I've never seen, that if it's not grown, it has to be mined, and which I think is funny. It's interesting, but there's actually a lot of work going into growing using biology to recover heavy metals in the environment, whether it's from mining tailings or from brown sites. And, you know, in my view, architectural ceramics is a really interesting place where some of those heavy metals could go as colorants for glazes, both to sort of as a poetic gesture, perhaps, but hopefully more than that, a kind of replacement for some of the mining that happens currently. And so if I really look forward far, I think that's kind of an interesting area of research. So, all right.
Super. Great, Andy. So there's some questions here. I think one had to do with your stall diagram and just trying to understand that a little bit better. What the three dimensions? Some were cones, some were cylinders, and so yeah. What were you trying to represent there would be maybe helpful.
Okay, sure. Yeah. So I really put it in less of sort of as a description of how a larger group of people would describe glazes, but really more personal to the research happening here, and that I share, of course, with Boston Valley. So for the temperature range that Boston Valley works in, there's really 3 ways to get glazes to melt at that temperature, right? There's, and one involves zinc and boron, and then you have like a fritted lead, not raw lead, no raw lead is used, but a fritted lead. And so I'm mapping out, really I specialize in the sort of zinc glazes and boron glazes. And so they all, you know, let's see, I kind of break it down. So like boron glazes are amazing, but they tend to pinhole more often. And so by mapping the boron levels in different glazes, I can start to see when something like pinholing is happening or different other traits, and I can quickly see how much zinc or boron is in the glaze. So in my particular case for that example, they were mapping out zinc in the Z direction and boron also in the Z direction, but with a different shape, either a cone or, you know, a polygon.
Another, just on the recycling of glass, these glass cullets that you're sourcing, are they pretty good in terms of control from different lot to lot, or is it?
Yeah, so that's something I've been working on, sort of figuring out for some time. And the cool thing is it's sort of post-industrial, so there's a high level of control already. Right, there's an incentive for the actual company producing it to sort of not have their waste. You know, something's going wrong if it's varying a lot. And but by blending, I think there's 2 strategies to sort of how to deal with this. I mean, so many, even though Boston Valley projects are huge to me, some of them are relatively small in the grand scheme of things. So I think it's one, maybe not my first choice, but I think a backup would be to batch the glaze for the whole project, right? If you found yourself in an area where the glaze was particularly finicky. But so far, knock on wood, things seem really stable and seem to be coming out quite nicely, and you're able to predict. And it kind of goes back to some of those categories I mentioned, which is like sort of how flexible the client is and how much of a part of the story that is, right? Like when I look at architecture that I find just really compelling, there's usually huge amounts of variation in the glaze on a building project. And it's usually sprinkled throughout, right? Because it's not concentrated on one spot in the building, but it's sort of this variation. And of course, many firms want this and will in fact have 6 glazes mixed up that all slightly vary as a way of sort of getting this variation. So I think, you know, figuring out ways to navigate that is something that people are doing right now.
Super. So I think with that, if there are any more questions, please do put them in the Zoom chat. I think some people have been raising their hands, but we really can't get to you directly. It's just much easier if you put your questions into the chat. So Andy, thank you. Thank you, John. We're just going to now take a very quick break and go to our last presentation, which is the academic groups.